Hi all, I am here with my new video on chapter Energy and Chemical Reactions. Let's start. In this video, we are going to learn about potential energy diagrams. Potential energy diagram for exothermic reaction. Let us consider the exothermic reaction in which reactants convert into products and liberate heat. The diagram on the next page illustrates the potential energy diagram for exothermic reaction. In this diagram, the potential energy of the system is plotted along the y-axis and a quantity called reaction coordinate which monitors the progress of the reaction along the x-axis. On this slide, you can see a potential energy diagram for exothermic reactions. A potential energy diagram is used to illustrate the progress of a chemical reaction and to provide qualitative information about energy changes within a reaction. Here is the explanation of potential energy diagram for exothermic reactions. Following events occur during the course of the reaction. At the beginning, the reactants contain a specific amount of energy, which is called enthalpy or potential energy of reactants. Additional energy is absorbed by the reactants and serves to break certain bonds and initiate the reaction, which is called activation energy. As the reactants absorb energy, they are transformed into an intermediate named activated complex. As the activated complex is converted into products, new bonds are formed and energy is released. The products also contain a specific amount of energy, which we call potential energy of products. Since more energy is released, the products are in lower state of energy than the reactants and the reaction is exothermic. The difference between the energy or enthalpy of products and reactants is heat of reaction, which we represent by del H. What is the activation energy or the energy of activation? The activation energy is the energy needed by the reactants in order for a reaction to occur, and it is represented by a symbol capital EA. Let us consider the endothermic reaction where reactants need to absorb energy to convert into products. The sequence of events in an endothermic reaction are exactly the same as the sequence of events in an exothermic reaction. At the end of reaction, however, less energy is released than absorbed and products are in higher energy state than reactants. On this slide, you can see a potential energy diagram for endothermic reactions. Self-sustaining reactions are reactions which continue to occur because the heat they liberate provide the activation energy for the reactants. Example, a burning match. Spontaneous reactions. Spontaneous reactions are reactions that can occur under a given set of conditions without the application of external work. During the course of a spontaneous reaction, heat will be absorbed or released to the surrounding without any outside assistance. An example of a spontaneous reaction. Ice can melt into water at plus 25 degrees Celsius and 1 atm, but water is not able to freeze at plus 25 degrees Celsius. When a reaction is spontaneous in one direction, it is not spontaneous in reverse direction. If a reaction is not spontaneous, it doesn't mean that it can never occur. The reaction can be forced to occur if external work is applied to the system. Factors that enable a reaction to be spontaneous: energy and entropy. Energy: system changes from higher energy state to lower energy state. Reaction can occur easily when they are exothermic, means they release more energy than absorbed. Heat of reaction, which represented by del H, is negative. Entropy, the disorder factor. System tend to reach a state of higher disorder. Disorder is measured by a quantity called entropy and symbolized by capital S. What is entropy or disorder factor? Event circumstances that lead to a system into higher disorder are following. When the temperature of a system is increased, it increases random motion of particles which are present in the system. There are a greater number of products than reactants in a chemical reaction. There is a phase change. Gases have the most disorder, then liquid, and solids have the least disorder. The structure of products are simpler than the structure of reactants in a chemical reaction. A substance is placed in solution. When entropy increases, a reaction can occur more spontaneously. For example, here you can see 2 mole of potassium chlorate, which is in solid state, converts into 2 mole of potassium chloride, which is solid, and 3 mole of oxygen, which is gas. In this reaction, products are simpler in structure than the reactants, so entropy will increase. Transfer of energy. Problems involving heat transfer utilize the relationship Q is equal to Cp multiplied by m multiplied by del Tc. However, this relationship must be used twice, once for the object that releases heat and once for the object that gains heat, because heat is conserved in these problems. We can write this as following: Q lost is equal to Q gained. Q is equal to Cp multiplied by m multiplied by del Tc lost equal to Cp multiplied by m multiplied by del Tc gained. The vertical bars means that we are interested only in the absolute value of the quantity, not in whether it is positive or negative. Thermal equilibrium. When two objects with different temperatures are brought together, the heat is always transferred from hotter object to cooler one until both of them reach at the same final temperature. This event is called thermal equilibrium. The temperature is known as the equilibrium temperature. In our next video, we are going to learn laws of thermodynamics. So please like and subscribe to watch my new videos. Bye bye for now.